Okay, number 24 tells us that we have an ellipse, and it gives us the equation of the ellipse, and it's just in terms of a and b. So when we're doing this problem, you just treat a and b as constants. So an ellipse looks something like this. It might be longer this way, it might be longer up and down. Typically the a portion's longer, so that's why I drew it this way, but it doesn't really matter. And we're trying to maximize the area of a rectangle that's inscribed in there. So the rectangle would be something approximately like this. Obviously, I need to shift that a little bit. Okay, so the nice thing about an ellipse is it's going to be symmetric about the origin, symmetric about the y-axis. All the pieces and all the quadrants are the same, right? So when I'm doing the area of this rectangle, I can find the area of this rectangle and do what with it? Multiply it by 4. So that's what I'm going to do. And I know any point on this ellipse, I can just call x comma y. So if I call this point x comma y, that means the length across the bottom here is x, and that means the height up the side here would be y. So what's the area of this smaller rectangle? X times y, and I have 4 of them, so my area is 4xy. And this is my primary equation then. What's my secondary equation? The one that they give you here. And I know I worked through this with some people, but I'll work through it again here. So what do I do with my secondary equation? Solve for one of the variables and then plug it in, right? Because right now I have 2 variables here. I want to just get it down to 1. So it doesn't matter which variable you want to solve for. But y? Okay. So let's get the y by itself. So I'm going to subtract this piece over. So I'm starting with y squared over b squared equals 1 minus x squared over a squared. And I'm trying to get y by itself, so what's the next step? Multiply by b squared. And you could distribute the b through. I'm not going to, just because I'm going to have to factor it out again in the next step. So let's see here. There we go. So if I multiply by b squared, I get y squared equals b squared times 1 minus x squared over a squared. And again, you could multiply that through, but it actually saves another step if we don't. And then to get y by itself, I do what? Square root. And I'm just talking about the first quadrant here, so I don't have to worry about plus or minus. I'm just dealing with the positive portion of it. So y is actually equal to the square root of this. Questions on that part of it? And I'm going to plug that into here, but before I plug it in, I'm going to try to simplify it a little more. So what can I do with that b squared that's factored out front? Take a b out, right? So I have y equals, and the b's taken out. And then what's under the square root is what's in the parentheses here. Let's get a common denominator. So what would my common denominator be? A squared. So if my common denominator is a squared, what do I have in the numerator? A squared minus x squared. And this is the same thing as the square root of the numerator over square root of the denominator. So can't I take an a out of the denominator then? So this turns into b over a, good. And then square root of a squared minus x squared. Questions on that? Do you see how much simpler this looks than this to plug in? So now my primary equation is going to be the area in terms of x equals 4x, and then my y is going to be this. And remember, all your a's and b's are constants here when we're doing this. Questions there? So being my b over a is a constant, I'm just going to lump it with the 4 just to make it a little bit, I don't know, more concise here. So I have 4b over a times x, and then times the square root of a squared minus x squared. And what do I have to do with that? what did we say? Take the derivative, right? So a prime of x. And to do derivative, I need to use the product rule. So let's leave the 4b over ax alone. And the derivative of this, pull the 1/2 down. Yep, a and b are just constants. So when I take the derivative of a squared minus x squared to the 1/2, I pull the 1/2 down, I leave the inside alone, it's to the -1/2. Now what's the derivative of the inside? Just -2x, because this is a constant. When you take the derivative, it's 0, so it's just -2x. So questions on that? And then I'm going to leave the back piece alone, and what's the derivative of 4b over ax? 4b over a, just that constant. And then leave the square root piece alone. And we'll clean this up. It's not going to be as bad as it might look. So I've got this 1/2 and this 2 are going to cancel. And let's kind of write it as like a numerator and denominator for this piece. So in the numerator, I've got 4b, x, and a negative. So I'm going to say -4b x squared. Does that look like everything? So I took care of the 4b, this x, this negative, and this x. And in the denominator, I've got what? Good. A times the square root of a squared minus x squared. Questions there? And I'm just going to rewrite the derivative so I don't forget what's what here. And then back here, this would be in the numerator, so I'll just write it as 4b square root of a squared minus x squared, and then that's over a. And if I'm going to have to set this equal to 0, it's going to be easier if I get a common denominator. What's my common denominator going to be? This whole thing here, yep. So I'm going to multiply by my square root piece on top and bottom back here. And like I said, it's not as bad as it looks, because what happens when I multiply these square roots? It just goes away, right? So that actually makes it a lot nicer than what you might think there. So the numerator, I have -4bx squared. And then this is going to be 4b times a squared minus x squared, so you can distribute the 4b through. So it's going to be 4a squared b, or ba squared, doesn't matter, minus 4bx squared. Does that look right? And what do you notice? Yeah, you have 2 of the x squared pieces. You can combine those together. And then the denominator, I still have this. This is beautiful, huh? Pretty nice. Good algebra problem. And once I have the derivative, I set it equal to 0. So it equals 0 when the numerator is 0. So the numerator would be -8bx squared plus 4ba squared is equal to 0. So I'm going to add this over just because it's a negative. So I get 4ba squared, which is just a number, is equal to 8bx squared. And what am I trying to solve for? X. So what would I do? Divide by 8b. And back here, the b's cancel, and this 4 would make the 8 a 2. So I really get a half a squared, or a squared over 2, equals x squared. And then to solve for x, square root it. So if I square root this, square root of 1 is 1, square root of 2 is square root of 2. And then square root of a squared is just a. So you could leave it like this. You could write it as square root of 2 over 2 if you rationalize it, but that's my x value there. So questions on that? So that's my critical number. What am I trying to do is I'm trying to maximize the area. I'm going to allow you to just assume that this is a maximum rather than throw it on a number line and try to think through it. Okay? So this is where our max occurs. And what does the question actually ask for 24? Find the area. So if I'm trying to find the area, I can plug it back into really any of these up here. I'm going to plug it back into maybe this one here. So I know my x is that, and I'm plugging into this one right here. So my area, whoops. This is going to be 4b over a. And instead of x, I'm putting square root of 2 over 2a in its spot. And I'm just rationalizing it because that's what I'm used to doing. So that's my 4b over ax. And then I still have the square root of a squared minus x squared. And my x squared, can't I just go back a step and see it's a half a squared? Or a squared over 2. Is that okay with everybody? And then just cleaning it up. Here, an a cancels. Here, this 2 cancels and leaves this as a 2. So it looks like I get 2 square root of 2b. Is that everything there? So that's this whole front piece. And then back here, I'd probably get a common denominator. So my common denominator would be 2. So I would have 2a squared minus a squared. Does that look okay to everybody? This is actually going to work out really nice. What's 2a squared minus a squared? A squared. So I have the square root of a squared, which is just a, over square root of 2. And then I have 2 square root of 2b here. So the square root of 2's cancel each other out. So really I just have 2ab as my area at the end. Has anyone checked the answer for it yet? That's it. I think that's all it was asking for, right? Yeah, easy.